Hey, everybody. Happy Friday. Welcome again to another episode of our Friends Friday cast. We're really excited to have you here. Today, we're really excited about kind of diving a little bit deeper into web app vulnerabilities and application security. We've got a good friend here, Abraham Aranguren. He's with 7A Security. And not only do they do testing, but they also do a lot of training and specializing in app and mobile and embedded and all that jazz. And so this one was fun for me to kind of get ready for because, as people may or may not know, I was a web app pen tester for many years. So my focus in penetration testing was in the application security space. So, but it's been a few years now since I've actually truly been on an engagement. So I love kind of just learning about some of the new tips and techniques, and I hope everyone here would as well. So so Abraham, why don't you just do a brief introduction of yourself, and then what do you have to share with us? I mean, I'm going to poke and ask questions as you kind of share some of the stuff that you've got, but I'm really excited to learn more. So.
Awesome. So if you can put up my slides, I can maybe get started.
Yeah. There we are.
Awesome. So today we will be talking about the value of public pen test reports and some interesting vulnerabilities. So I'll show you first the brief, who am I, and then I'll just show you a few examples of mobile app vulnerabilities, web app vulnerabilities, cloud vulnerabilities, and some VPN application vulnerabilities. And then at the end, hopefully I have 100-something slides, so we'll see. I'll do an Electron remote code execution through purge pollution, which I think will be a very cool demo. I'll just jump straight into that demo because we don't have time for a lot. So yeah, I'm the CEO of 7A Security. And we do pen tests and training, so mostly application security. We work a lot with the Open Technology Fund to secure people in vulnerable situations, for example, people in Russia, Iran, China, who have to use some open source software to protect themselves to access the less censored Western internet, as opposed to the Iranian internet, for example, where you can only see what the Iranian government wants you to see. I'm also the co-author of the mobile web and desktop application security courses that we have. We teach these courses at all conferences all over the world. So Black Hat, Hacking the Box, OWASP Global AppSec, LastCon, 44Con, Hackfest, NullCon, SecT, and many others. So, for example, we will be at OWASP Global AppSec San Francisco this month. So I'll have a link to that at the end. I'm also the founder and one of the leaders for OWASP OWTF, which is an OWASP flagship project. If you type owtf.org in your browser, that takes you to the OWASP project page. And this is a link to my SlideShare for some previous presentations. And then I was a developer first, and then I switched to security. So if you are a developer or you are a pen tester, I understand, both sides of this, right? I know the frustration and challenges of developers that have to make it work in production by Friday. And I'm also aware of the frustrations of penetration testers when the vulnerabilities, the cool vulnerabilities they find are not fixed, right? So today we will be talking about some pen test reports from this is the list of the most recent ones. You can go to 7asecurity.com publications. You don't have to register anything. So if you just go to this link, you just can click on any of these reports and you download the PDF directly. You don't have to register anything. These are all completely public, no paywall, nothing. And yeah, so these are some of the ones we published this year so far. Litmus Chaos in Open Telemetry, we found a couple of CVEs. This is a very cool pen test report to check, because we found you could basically denial of service the entire solution by just sending a single curl request, exploiting the compression. So this is a very interesting public report to look at. And then there's V2Ray, it's also interesting. And Cover Drop is very cool. This is a protocol devised by people working at The Guardian newspaper in the UK. So basically you can hide who is the source from the journalist by making all the users of the newsreader application kind of fake that they are sending messages to the journalists, even if they are not. So they have an entire open source protocol to do this. The Guardian newspaper in the UK is already using it, but any newspaper can use it as well, because this is all open source. So here we audited the mobile apps, the servers, the AWS cloud configuration, Kubernetes. We also put together a threat model and a supply chain audit, right? So depending on the audits, like some of these are like very comprehensive, doing a lot of things, and we always try like to highlight a little bit what each pen test is about, right? So these are just some of the examples, and these are from 2022. So today I'll highlight some vulnerabilities from the Live Home Safe app, which was a COVID-19 contact tracing app enforced in Hong Kong. So people were basically forced to like scan this a QR code in the mobile app whenever they left the apartment to do anything, right? So if you wanted to go to a restaurant, to take the underground, to go to the gym or anything else, you had to scan this code everywhere. And because of the political situation in Hong Kong, there was a concern about like the privacy implications of this, right? So this is what triggered the audit. And the privacy was decent, but the security was very bad. So I'll highlight some of the highest severity findings from that audit during this presentation. Another interesting apps or previous work is like Smart Sheriff. So you can see the slides on the video of a previous presentation here. This was a mobile app mandated by the South Korean government. And then there's Chinese police and cloud pets, right? So this is like a little bit of mobile application security, but also like with IoT toys and the implications of having a toy that records audio or plays video and things like this. Like to do that securely is kind of difficult because like in with toys, like the budgets are limited and so on. So the security of this was really bad. It was so bad I gave a talk about it, right? So you can search for these presentation names on YouTube, or you can just click directly on the links and we'll make the presentation available as well. So let's just jump into examples because we have a lot to go through. So one of the things we tend to find most mobile apps being vulnerable to is task hijacking, right? So this is kind of a forgotten vulnerability that was patched by Android, I think in Android 11 or 12. But because mobile apps still support like Android 6, Android 5, and so on, this is still pretty much a still applicable attack for a large number of application users, right? Because there's a lot of people using outdated Android devices, right? So basically, I'm just going to jump through this, but I prefer presentations to be useful on their own without listening to the speaker. So this is why the slides I have more details, but I'll just jump to the chase here. So in this case, this is vulnerable to task hijacking because the activity has a launch mode of single task, and this is like the launcher activity, right? So we can manipulate this, and I'm going to show you how in a demo. Let me try to see if I can share my entire screen. I think will be easier.
Yeah. And while you're doing that, I think like what's interesting, to me is like there's just continued ways to find research, for AppSec pen testers and AppSec folks in general. Is like there's lots of resources, and there's even more than when I was doing testing, and so like it's a great way to kind of stay up on your skills, right? So like, go ahead. That's just one of the takeaways. Kind of reflecting on it.
Yeah, definitely. So basically here we have the Live Home Safe application, and this is the login screen, right? So you have like the credentials and so on, and this is now in the task for Android, right? The task list of apps. And now, so maybe I'll slow it down a little bit. And then when you click on the attacker app, so first you open the legitimate app, right? So this is the Live Home Safe application. This is the login screen, and you can see that the Android task list of open applications, right? So Android fakes, and iOS does this as well. But in this case, right, for Android, what we are attacking is that Android puts together a task list to fake that the application is faster than its release. It takes kind of a screenshot and it puts it in the task list, right? So you can see the apps that you have opened at the moment. And here we have the Live Home Safe app, right? So what we are doing now with this task hijacking attack is that we are clicking on the attacker app, and now this click, or in a real device, it will be a tap with your finger, right? When you tap on the attacker app, what this attacker app is doing is it's messing with this task list of Android, right? So when you click on the legitimate app again, instead of opening the legitimate app, you are opening the attacker app. So the idea here is you would have an attacker app installed on the device, like a lot of banking Trojans do this. And then in this case, instead of looking like attacker app, this would look exactly like the login page of the Leave Home Safe app, which was the target application in this case. And then the user basically has no way to tell which is the legitimate app and which is not, right? Because like in the user interface, everything looks the same. The user is just going to enter the credentials into an attacker controlled app. So the attacker will have the login and the password of the user, right? So task hijacking is a kind of forgotten attack that most people don't report in mobile app reports, but it's still pretty much applicable, right? And in the Leave Home Safe app, it was one of the findings we had, right? So let me see if I can make this bigger.
And so with that, you, as an attacker, you would need to have deployed your attacker app to the App Store and somehow get them to get
or somehow make the users like install your app. But what you are really attacking is you are fooling the user. Like when they are clicking on the legitimate app, they are really opening your app instead of the legitimate one, right? So that is what task hijacking does, right?
Yep.
So this would be the way to fix it, right? So you can actually, in Android, there's a mechanism to prevent this. You can put like on the application tag, you can set task affinity to an empty string. So basically it will not be targetable through task hijacking. And then you change the launch mode to single instance on the launcher app, and then you are pretty much set, right, to fix it. Now let's look at another vulnerability on the Leave Home Safe app, right? So basically, this was saving QR codes that revealed like when the user, so it stored like COVID vaccination and COVID test status images on the SD card. So this was the problem. And why is this a problem, right? Because on Android, the SD card is kind of the Wild West of Android because of two things, right? So you can have an unskilled thief who can extract the SD card and plug it into a computer and then read all the data there without having to know the PIN or the unlock pattern. And then the only requirement would be for apps to have like SD card access, right? So any app with SD card access can read anything on the SD card. So this is why this is bad, right? So in this case, what we did was, so you enter here to see your electronic vaccination and testing record. And here there's an option to import your vaccination record. And you could choose this from a safer location, right? So for example, in this case, we're using Google Drive, right? Google Drive requires you to be logged in with your Google credentials. Probably you also have two-factor authentication and so on, right? So we are like uploading an image from this safe location into the app, but then the app made the mistake of uploading this to the SD card, right? So you could verify this by just doing adb shell and ls. This is basically listing the contents of this folder in the SD card. And we found like these images would stay in the SD card even after like a device reboot and everything, right? So this was available all the time afterwards, right? So basically like anybody can extract the SD card and read all these like sensitive information, right? If you are like infected by COVID or you're vaccinated or not to COVID, and all that would be accessible for everyone, right? So the solution to this would be to avoid using the SD card for storing sensitive data and so on. And yeah, I'm just going to jump a little bit into the next because we have a lot more to go. So another one that we found was this COVID status access through an auth bypass, right? So this is actually a vulnerability in mobile apps that happens a lot, which is that the application implements some sort of a touch ID or fingerprint or Face ID or some sort of a passcode or a PIN code that is required to open the app or to access something sensitive in the app, right? So in this case, the application had an option to enable authentication to access COVID vaccination and test status, right? So it's required a PIN or a fingerprint to access, but this feature could be trivially bypassed due to a logic flaw, right? So this is actually a very trivial attack that will work against a lot of apps implementing similar functionality just because the developers didn't think like an attacker, right? So basically you can just skip, like tap through the screens, and it just requires minimal effort. It's basically an attack like even your grandmother or your grandfather can do, right? It's like very simple. So you can just navigate to the settings, you enable authentication, you see that the Touch ID is required, but then you can, or in Android, you would enable authentication. It would require the fingerprint to see the COVID-19 vaccination records. So until here, everything is as it's supposed to work. But then what we need to bypass it is just to go to the settings and disable it, right? So you click on this, it requires the Touch ID, but then you go to the settings, you disable it, and now you have access to the screen that previously was requiring Touch ID, right? So the solution would be to require Touch ID again when you try to disable this, because otherwise this setting is doing nothing, right? And in Android, you could also do the same, right? So this attack affected both Android and iOS. So this is like a logic bug. It's kind of the future of security, right? Like access control and logic bugs are going to be with us for a long time, because like there's really no framework that can save you from things like this, right? This is just a developer mistake. So yeah, let's do a quick demo about this. So this is the bypass, right? So we're basically enabling the authentication, right? And then you go to this to view your electronic vaccination record. And as expected, it's requiring Touch ID, or in Android, it would require the fingerprint. But then if we go back to the settings and we disable it, right? So now in this case that we tap on it and it's requiring Touch ID, right, as expected. And then if we're just closing the app and opening it again just to make sure, like there's no caching vulnerability. So this is like all kind of working as intended, right? But now what we're going to do is cancel that, go to the settings, and then we go to the application settings. We disable the Touch ID from the settings. This required no Touch ID again, as it should, right? And then this allows us to now go to the electronic vaccination record without the Touch ID again, right? So that is basically the attack. So yeah, the recommendation would be to ask for it again. And now the worst that we could find in the Live Home Safe app, if that was not enough, like 8 million people were forced to use this app in Hong Kong, right? This is like really bad, right? It was so bad I gave a talk about it, right? You can search it, like it's called Live Home Safe, the good, the bad, the ugly. So this is the bad, right? The ugly was the disclosure and the politician statements, but we won't get into that here because we don't have time. So the worst that we could find was man in the middle in Android without warnings, right? So the only requirement for this would be some capacity to man in the middle traffic. So you could do this with public Wi-Fi without guest isolation, with BGP hijacking, with ISP man in the middle, but even with DNS rebinding, right? So DNS rebinding would be more serious because you can do this like from anywhere in the planet, as opposed to having to be like in the same network as the victim user, right? So we could basically intercept traffic between the Live Home Safe application and its backend server. And this is how the attack worked, right? So basically, when you man in the middle with burp, the burp certificate authority has to be trusted by the device, right? So this is all working as expected. And this is normally like in the certificate tab, in the proxy tab on burp, you normally enable this setting here, generate CA sign per host certificates. And if you can man in the middle with this is kind of normal, right? Now, what we are doing here is slightly different, right? So we are using a CA sign certificate with a specific host name of 7asecurity.com. This could be attacker.com or whatever, right? The point is you have a domain on the internet like attacker.com. And what you are doing is you get a certificate from a certificate authority that is going to be trusted by the device. For example, Let's Encrypt, right? Let's Encrypt will give you a certificate for free for the domain you have, right? So if the attacker owns some domain on the internet and can somehow pull off the man in the middle, like open Wi-Fi without guest isolation, for example, then the attacker can send the CA sign certificate, like a certificate signed by Let's Encrypt, valid for attacker.com. And then the application would accept this, right? So this is like a comparison of what the Android browser would show, which is a security warning, which would be like expected behavior, right? Like we are showing a certificate that is not valid for this domain, therefore the Android browser complains about it. But in the Leave Home Safe app, there were no warnings at all, right? So you could man in the middle the login page with the username, the password, and everything else, and you could like man in the middle the login credentials without any user warnings whatsoever. Also the second factor, and also like in other screens, like when you reported that you were infected by COVID, you could see the report, the name, and so on, and also like the verification code. You could man in the middle all these without warnings, right? So this was all very bad. And this is why, so this is the man in the middle of that. And this is why it works, right? So normally if we had an audience here, I would ask people to find the vulnerability. But basically, there's two parts of SSL validation, right? So one is the certificate signed by a certificate authority? That part of the validation was correct. And another very important part of SSL validation is the hostname verification, right? So this is what the hostname verifier is supposed to do in Android. And this would be the default behavior in Android, right? So use the Android functionality to validate the hostname. However, they had this checking here saying the equivalent of if this server I'm connecting to is this very important server where the Hong Kong people enter the credentials for the health system, then return true. Basically, skip validation, right? Ignore a mismatch in the host. And this probably because, like we speculate, right? Like in development, they probably had like an invalid certificate or something, and they needed this for whatever reason, but they forgot to remove it when they released into production. Mm-hmm. So you have 8 million people using this vulnerable code that basically allows anyone with a domain on the internet to man in the middle everything, right? So this was very bad. How much more time do we have?
We've only got a couple minutes, as we're kind of wrapping up here. But I mean, this has been fascinating. Yeah. So
yeah. Okay. Then the way to fix this would be to improve the TLS validation. Another thing that could be done is to use pinning, right? So OWASP has a pinning cheat sheet with examples for both Android and iOS to secure communications further, right? So basically, with pinning, what you do is you only trust the server that you are connecting to, and then what this is going to do is even if the certificate is signed by a valid certificate authority and everything else, if the certificate is not matching the certificate expected by the mobile app, it will reject it, right? So it is a much stronger form of validation, because even if you have an attacker, like the Chinese government or some other governments that are trusted by Android or iOS, they can still not forge a certificate that matches the certificate in your server, right? So this is why pinning is like so much stronger, and it defends you from that. So since we are short on time, what I'm going to do is just skip to the end, and then maybe we can do the rest of the presentation, because I have like 50 more slides, right? So
we can follow up. Yeah.
So I'll just jump to the end and briefly mention a few things. So in September 23rd and 25th, so from September 23 to the 25th, we have the OWASP San Francisco training, right? So there's OWASP Global AppSec San Francisco. So we are teaching a web hacking course there. We're also running a free pentest contest this year. So basically, this is like a completely free pentest, no strings attached, that we do every year, right? So everybody can apply for this, and then there's a winner that is chosen, and then the winner gets a pentest for free, no strings attached. You don't have to pay absolutely anything. So we always do one of these like every year. And we also set up a couple of discount codes for the podcast listeners, right? So if someone is interested in a pentest and doesn't want to join the contest because you need it sooner, you can use the Friends Friday 1,000 to discount, so you get 1,000 off your next pentest. And if someone is interested in our courses, they can use Friends Friday 40 for 40% off. And if you're just interested on the free stuff, we have some cool free workshops. So these are all completely free as well. And they teach you about mobile hacking, web hacking, and also like electron hacking, right? So you have, I think, for example, the mobile hacking course, we have one called Practical Mobile App Attacks by Example, which is basically a lot of years of mobile pen testing in 4 hours, right? So if you get that free workshop in 4 hours, you learn a lot about mobile security. And I think the web one is like an hour and a half, and the electron one is like an hour or something. But basically, you can learn a lot for free as well. And since we talked about the public reports, yeah, there's another link here. So 7security.com publications. So in there, you can go in this link and you can download all the PDFs for free. You don't have to register or anything for the public pentest reports is all available there for free, right? So that's pretty much all the time we have. I'm not sure if you have time for questions.
No, this is great. So yeah, no, if again, this is all part of, for our audience, this is all part of our Hack to School month. I forgot to mention that at the end. So we're kind of deep diving into some more technical topics and just ways to continue to learn and grow your skills as kind of people are going back to school. But yeah, Abraham, thanks so much for sharing, just some of the fun techniques that people can learn about, and this brings me back to the days when I was doing mobile app testing and all those fun stuff. So this was great. So yeah, definitely check out the course over at OWASP San Francisco. Thanks again for offering some discount codes for our audience, and we'll definitely set up some more time to be able to dive even deeper on some other things. But I think just the key takeaways are, hacking can be a lot of fun, and also, highlight a lot of important things that can continue to get missed. And like you said, business logic flaws are the ones that I think are, going to perpetually be there with, as we move forward in this era of, hacking and coding and AI and all these things. So thanks so much. For those of you that if you have questions, feel free to leave them in the comments, and we'll respond to them as quickly as we can. So, but thanks everybody for a great Friday episode, and have a great rest of your day and a great weekend. And we will catch you next time.